Okay. That's basically what we have. So it's going to be the integral from -3 to 3 of the square root of 1 plus the derivative of that, which is x squared dx. Agreed? Can't hear you, Ian.
Yeah, that's what I got.
Okay, so you would look up that in the tables. Have you done that for me, or will I have to do it?
Yeah, I do. I think it was a formula that used square root of a plus or a squared plus u squared.
Okay, and what did that give us? The natural log of secant plus a tan or something, probably?
No.
What did it give you?
So u over 2 times the square root of a squared plus u squared. Yep. And then plus a squared over 2 ln in parentheses u plus the square root of a squared plus u squared. Yep. Plus
Okay.
c.
Yeah, plus c. Okay, in this case, then u is just x and a is 1. So it's going to be x over 2, 1 plus x squared, plus 1 over 2, the natural log of 1 plus x squared, evaluated at -3 and at 3. That's as far as you've got?
Yeah, I got that far.
Okay, so let's put in some numbers. You put in 3, you get 3 over 2 root 10 plus 1/2 the natural log of 1 plus root 10. Ooh. Take away negative 3 over 2 natural log of 10 plus 1/2 the natural log of 1 plus root 10. So what's that get me? It gets me 3 over root 10 plus that ugly log. Take away is an add, so 3 over 2. Square root of 10. Square root of 10. Take away a half ugly log. Well, they two kill each other off, and those two get added, and the answer is 3 root 10.
Yeah, that's what I put in for 10.
And it didn't.
No, I'm not getting the right answer.
Okay, let me go out and then see if I can see their solution to that. So this is arc length. What question was that again?
10.
10, okay. Arc length 10. Well, I've got -5 to root 5, but I mean, that's just a change in numbers. It's not a change in method.
Yeah, mine is -3 and 3.
Right, they just doubled it up. And they said by symmetry. Okay, well, by symmetry. Okay. Do you know how you've got the integral from -3 to 3 of 1 plus x squared dx? Right? Okay. I think when you look at the tables, they're only allowing you to do it.
I need to see your screen. Oh. No, thank you.
Okay. Just letting some people in. Okay. And this is a little bit sneaky, but it is what it is, so we'll just have to live with it. It's the bisymmetry that caught me. See, when you look up the tables for that, the tables are from 0 to a number. That guy, if you draw him, is symmetric. So what they did is they only found 0 to 3 and then doubled it. So see if you take that answer and double it. The two end terms don't cancel out. The two end terms double up. That's where the difference is. So when you look at the table of integrals, the table of integrals for this fella assumes that that number is 0. Now, I don't know if they see it or they just have an assumption or whatever, but that's what the problem was. So when you were using it to do this fella, what you had to realize it was two of these fellas. That's, I don't know, I haven't had a chance to look at it. Maybe when you go and look at the tables, it will make that restriction that X is always greater than 0. And if it does, then that's fine. And if they don't say that, then they really should have, because it's kind of unfair to expect you to just know that as an obvious fact.
Yeah, at least on the table it says A is greater than 0. But
Well, there you go. That's probably as close as they can get.
Okay. So, yeah. So when I used A is -3.
Right. So what you do there is you had to make A positive, and that means you have to start at 0 to 3, and then the -3 to 0 is the same area as the 0 to 3, and that's why the double up worked.
Okay. Thank you.
That was a sneaky one.
Yeah.
I don't think it happens much. I think most of the time, the numbers you get, you don't even think about it because they're just usable. You know, 1 to whatever.
I guess I think I misunderstood it because we use A in this case as 1 when we replace it. But yeah, I don't know.
I don't know. It's an idiosyncrasy of what the tables are telling you, and they're telling you positive X's, even though they don't mention it. And they are mentioning positive A's, but they should have mentioned positive X's as well.
When it comes to something like that, I can just use the absolute value of the negative bound.
Well, all you need to do is realize by symmetry, the -3 to 3 area is the same as the 0 to 3 area doubled up. Right. If I draw my little picture to show you what's going on.
Yeah.
You're trying to find this particular area here. Oops, -3. The 3, that's negative. What I'm saying is that the integral from -3 to 3 of that guy is the same thing as just finding 0 to 3, which is this one, and doubling it up.
Yeah.
And this guy you get from the tables. And whatever it is, it's something √10 with a really weird log. And then whatever that number is, you just double it up.
All right. Thank you.
Good morning, everyone. How is things? So how are you today, Matthew?
Good, how are you?
You're a bit quiet today. I think either it's mine or yours, but I think it's maybe yours. Your volume control. That's better.
Okay.
How are you, Emma? Good.
Same old.
Same old, same old. James, what you got today? Flying over some trees. Gotcha.
I've been doing a little bit of math. I think that I can stop the chemistry course now and pass with a grade.
How's this? Is the chemistry course? I don't know. How can you pass right now in your chemistry?
Well, I mean, it might be a 0.8 or 2.0, but
No, we don't like that. Yeah. We want 4.0s. Even if you don't get them, you want them. So you try for them. What about you, Douglas? How is life?
Pretty good.
Good. Oh, we got 2 chats. Emma's wanting to tell us something. I did your survey. I had a survey. Meaning me.
No, it was a student survey. Matt was telling me that he completed it.
You did a student survey, Matt.
Yeah, she emailed me and I did it. So yeah.
Is this anything I really need to know, or are you just something I should have kept out of?
I mean, it was like for one of her other classes.
Okay, so the social sciences or something wanted a survey done, so Emma sent it to people. Gotcha.
Pretty much, yep.
Right. We about ready. God in Himmel, look at the time. Okay, everyone. Sorry for keeping you in. I just totally lost track of time. Okay, I want to show you some stuff here. This is what we're going to do today. Improper integrals. There are 2 types. I finally found out which one's called type 1 and which one is called type 2. I think I said it the wrong way around, but I can never remember. The one that has an infinity in the integral, right? Like here, for instance, is an improper integral of type 2. And the one that has a vertical asymptote, like this one here does, these are called improper integrals of type 1. Now what I've got over here is a little shopping list of how do you find an improper integral of type 1. You know, ones that look like this. You replace the infinity with a t, and you change the question into find the limit as t tends to infinity of this guy. Or sometimes you change it to negative infinity.
I'm in
Sorry?
class.
Say again?
Yes.
Have we a question or just background sound? I'll mute it that way. If you do have a question, you hit spacebar. There we go. So, as I was saying, oops, I just realized that shouldn't be there. You either do an integral from, say, a number to t, or from t to a number, depending if t is positive infinity or negative infinity. You then find that integral. You then find that limit. And you're probably going to do things like L'Hopital or brute force. And then you have a conclusion. If that ends up being a number, we say that the limit, the original question, this fellow here, converges to 4 or whatever that number is. And if this limit ends up being infinite or undefined in some way, then we just say that the limit diverges. So that's the process. Let's do an example of one to show you why the process sort of works. Suppose I'd like to know for that function whether or not the integral from 1 to infinity, what it's equal to. So we know this is type 2 because it has an infinite in one of the intervals, limits of integration. So it's going to become the limit as t tends to infinity of the integral from 1 to t. Now, since I'm going to have to integrate 6 over x squared, I'm going to rewrite it as that. And now I'm going to find the integral of that. Well, according to the power rule, you add 1 to the power and you divide by the new power. And you evaluate it from x equals 1 to x equals t. And that becomes the limit as t tends to infinity of, well, I'm going to do style points on it. If you leave something like that, you're just asking for trouble later on. you need to return it back into its original form to make it easier to, deal with the limits and deal with calculations. So it's now going to be the limit as t tends to infinity of -6 over t, it's the first guy, take away -6 over 1. So I now am looking for the limit as t tends to infinity of -6 over t plus 6. Hey, we're almost done, aren't we? Okay, do not overthink this, fella. Can't we use brute force on this? Can't we just make t infinite and get an answer? Right? Let's see what happens then. -6 over infinity, add 6. What number is -6 over infinity going to tend to?
0.
And so 0 add 6 means 6. So we can now say that the integral from 1 to infinity of 6 over x squared dx converges to 6. And we like to use the word converges rather than says equal to 6. And that's a little nitpicky, but it does actually make sense. Now, if you went to your calculator and you do a sketch of 6 over x squared, it looks like that. And if you start at 1, it looks like that. And we have just found that the area of this is 6. And that might seem counterintuitive, because doesn't this right-hand side travel forever? Right? Yet, although it's an infinite distance, isn't it a finite area? The area is only 6. Which might hurt your brain, but it's true. The area under that curve is 6, or at least it converges to 6. Are we good? I don't hear any problems. Do we have any? Can I keep going? Just getting your head around it. Okay. Well, let's do something about this. Let me try and convince you that it does converge to 6. If I found the integral from 1 to t of 6 over x squared dx, doesn't the answer equal -6 over t plus 6? Would you agree? Okay, so what would the integral from 1 to 100 look like? Well, it would look like -6 over 100 plus 6. That would be 5.94. Suppose I did 1 to 1,000,000. Well, that would be -6 over 1,000,000 plus 6. And that would be 5.999994. Can you see what happens as this number gets bigger? Doesn't this piece basically disappear to 0? And doesn't the answer become, for all intents and purposes, 6? Does that convince you a little bit better than pictures? Do you see why it does actually work? It's not like, I don't believe you. It works. Okay. So let's look at this one. The integral from 0 to infinity of 1 over the 4th root of 1 plus x. Okay, if you have to integrate this ugly fella, you realize you've got to write him in a different form. Don't we have to write it as a fractional power? Because it's 1 over, won't it be a negative fractional power? So it becomes the integral from 0 to infinity of 1 plus x to the negative 1/4 dx. Are we happy about that? That this is him. So let's focus on solving the new problem. Well, that's going to be the limit as t tends to infinity of 0 to t, 1 plus x to the negative 1/4 dx. So you take the integral, replace the infinity with t, and make it go as a limit now, right? Change it to a limit. Right, next bit might be a little bit messy, but it is doable, hopefully. If you want to integrate 1 plus x to the negative 1/4, can't you use the linear shortcut method and just do a power rule? So add 1 to the power. Well, if you add 1 to this guy, you get 1 plus x to 3/4, right? Add 1 to the power. Divide by the new power gets you 4/3. Now, according to the linear shortcut method, if that x was 2x or 4x or 10x, wouldn't we multiply by a half, a quarter, or a tenth? But since it's 1x, isn't that finished? And we're going to evaluate that at x equals 0 to x equals t. Now, if you do not like the linear shortcut method, you know you could do a u sub and get the same effect about 3 lines later. So whatever you want to do, that's fine, but this still becomes that no matter what you do, right? So the integral of this is now that. Now again, style points kicks in. 1 plus x to the power of 3/4 is not a very convenient way of writing this. What does that look like when you turn it into a kind of 4th root kind of guy? What does that guy look like when you try and make him look more like this fella? Three quarters.
X plus 1 to the power, 3rd power.
Okay. Now we can plug in, oops, t, and we get 4/3, the 4th root of 1 plus t cubed. Take away, I'll save some time here. If you plug in nothing here, that's 1, and 1 cubed is 1, and the 4th root of 1 is still 1, so you end up with take away 4/3. Okay, this one can also be done by brute force. So let's find out what it would be. It's going to be 4/3, the 4th root of 1 plus infinity cubed, subtract 4/3. Okay. If you take infinity and you add 1 to it, it's still infinite. If you cube infinity, isn't infinity cubed still infinite? What's the 4th root of infinity?
Still infinity, right?
Right? And 4/3 times still infinity is still infinity. Isn't the bottom line that that's infinity? If you try and take 4/3 away from infinity, won't you really not dent it at all? So what we have here is that this limit will be infinitely large. And so your answer to this question, which is what is the integral from 0 to infinity of 1 over the 4th root of 1 plus x, your answer is it diverges. In this particular case, isn't the answer infinitely large? Right, the area is infinitely large.
So if it's a number, you say converges, and if it's
Yep.
infinity, you say diverges.
Yep.
Okay.
And if it's sine x, you say it diverges as well, not because it's infinite, but because the limit doesn't exist. So we kind of, anything that doesn't end up being a number is diverges. And there's a couple of different ways to diverge. Most common is, yeah, is infinite. But suppose I went and said to you, the integral from 1 to infinity of sine dx, wouldn't that also be diverges? Not because the area is infinite, because it's not really infinite. Isn't the problem that you don't know where to stop in infinity, right? And so the answer could be anywhere between 0 and 1. And so diverges is a catch-all for it don't have a numerical answer. Most of the time it'll mean it's infinitely big, but it doesn't need to. Sine x is an example of it just not working because the answer doesn't exist, right? Are we good? Right. So let's continue looking at example. By the way, that one there that we just did was something like number 4 in your homework if you want to get practice at it. This one is kind of like question 5, but I'm doing my own version of it. I'm going to do 2 versions of question 5. This is the first one. Okay, this is going to become the limit as t tends to infinity, the integral from 0 to t of 1 plus 2x dx. I think we should all be comfortable with that step, right? The infinity turns into a t and it changes to a limit. It's going to be the limit as t tends to infinity of that guy. Okay, 1 over 1 plus 2x. I'll take a volunteer. What's its antiderivative?
Natural log of 1 plus 2x.
Is there anything else you need to do because of the linear shortcut method? Or if you do it by u-sub, you'll have to do it for the same reason. There's something missing. That's correct, but there's something missing.
You need a half at the.
You need a half. And don't you need a half because of the 1 plus 2x, in particular the 2x? If that was 7x, wouldn't you need a 7th? If that was 20x, you'd need a 20th. Okay, we're ready to plug in some numbers in. It's going to be the limit as t tends to infinity of 1/2 the natural log of 1 plus 2t, take away 1/2 the natural log of 1. Okay, ready to brute force this. 1/2 natural log of 1 plus 2 lots of infinity. Oh, isn't the log of 1 0? So that's basically nothing. Okay, here goes. 2 times infinity is infinity. 1 plus infinity is infinity. What's the log of infinity going to be? The log of an infinitely large number.
Infinity.
And half of infinity is infinity. So there we go, we get a diverges. Now I said I'd do 2 versions. Let's show you the other version. Now that's going to be the limit as t tends to negative infinity, do you notice a slight alteration or change to the process because it's a negative infinity? Do you see it's now the limit as t tends to negative infinity rather than plus? And do you notice that the t goes here now? And I'm going to do a second slight tweak. Why have I put absolute values round the log function?
That's the rule.
Say again?
That's the rule.
Technically, it's a rule, but I don't always do it, do I?
Because we're never going to get a negative number.
Yeah,
You
we don't
can't
want
do that.
negative numbers. So in log, you know, in the log world, if you know the numbers are positive, which this is, you don't need to reference that absolute value, but here we do. So it's time for brute force. 1/2 the natural log of 1 plus 2t. Take away 1/2. Oh, yeah, 2 times 0, that's 0. Minus 1/2 the natural log of the absolute value of 1 plus 2t. And I still haven't done my limit yet. Okay, that becomes 1/2 the natural log of the absolute value of 1. Take away 1/2 the natural log of the absolute value of this fella. Okay, pretty much what we just did. Isn't 2 infinities infinite? Isn't 1 plus infinity infinity? And I should be putting my minus there. Let's do that again. 2 times negative infinity is negative infinity. Negative infinity plus 1 is negative infinity. The absolute value of negative infinity is positive infinity. The log of positive infinity is infinity. Bottom line is this guy is 0. Take away infinity. It also diverges. Are we good? Right. So we've seen a radical, right? A fourth root. We've seen a fraction that became a log, which is this guy. Let's look at exponentials. This guy's kind of like question 6. Suppose I do the integral from 1 to infinity of 3 times e in negative 2x. That's going to be the limit as t tends to infinity of the integral of 1 to t, same guy. I need to integrate 3e to the negative 2t. Okay, anybody having a shot at it? You can either do a U-sub, which will take you about 5 minutes, or you can do the linear shortcut. If you feel up for it, you can do, I would try and do the linear shortcut. What's e to the negative 2x going to get me? Well, its antiderivative is e to the negative 2x times what?
Is it -6?
Is it a half or 2? What do we use?
Negative
Oh,
3/2.
3/2 then.
All right, with the negative in it, right? So this becomes that. Now, if you don't like the linear shortcut method, well, you do u sub equals minus 2x, and it will eventually become that. Now, we're going to evaluate that at x equals 1 to x equals t. And that's now going to become the limit as t tends to infinity of -3/2 e to the -2t, take away -3/2 e to the -2. Now, sometimes you just have to do things that to make it work. Style points, this looks exactly like the original, which I totally agree it does. But if I leave it like that, I might not be able to figure out what's going to happen when t is infinite. So I would suggest that it might be helpful that I change it to that. You happy about this guy is him and that this guy is him. Now brute force again. Two infinities is infinite. E to the infinity is infinity. Two lots of infinity are still infinity. We are going to get that guy. What does -3/infinity get you?
0.
0.
So this guy converges to that number. Good. Now, suppose I try to do this guy. Do you think that guy's going to converge? Or will that guy be infinite and diverge?
Would it just be the same?
So you think it would converge?
I'm not sure.
Okay, let's visualize it. Isn't that guy there the integral from 1 to infinity of that guy? If you drew a picture, it would look like that. If you looked at this function, wouldn't it look something like this? What's going to happen if you change and go and do this piece? Can you see this piece is infinitely large and just going to get bigger and bigger? So on this side, it diverges. And on this side, it converges. So the moral of that story is that whether it's plus or minus infinity, right? Whether it's a plus infinity in the top or a negative infinity in the bottom, don't you have to do the question? Because they don't always get you the same answer, right? 1 to infinity is a number, and minus infinity to 1 is actually infinitely big, right? It diverges. So it's not the same. Now, if you had a shape that looked like this, if you did 0 infinity, or you did minus infinity to 0, because of the symmetry of this particular shape, won't the two answers be the same, whatever that same is, right? They'll both be a half, or they'll both diverge. So if you're looking at some functions, doing a little sketch can very often give you a little bit of insight into, well, that one's just going to go off to infinity, I can see that. Because if a function gets bigger and bigger and bigger, won't the area under it become infinitely large? I mean, there's no way around that. If it's going to converge, doesn't it have to get smaller and smaller really quickly? Because if it takes its time, the answer will end up being infinite as well. Like 1 over x is divergent, but 1 over x squared works. You know, very similar functions, but one has a divergence and the other doesn't. Are we good? Right. Not doing this one, just going to give you a heads up on it. It's got a couple of things that make it a little bit awkward. First thing is, do you notice the variables are not x? That's not a biggie, right? Can you turn into x's if it really bugged you? It's going to be the limit as t tends to negative infinity, 0 to t. And the last piece that I'm going to help you with, antiderivative of 4 to the r is 4 to the power of r times an ugly looking weird bit. What is the ugly looking weird bit?
One divided by r plus 1.
Nope.
No.
You're thinking power wrong, but no. That's not the weird one. That's pretty weird, but not the weird one I'm looking for. The antiderivative of anything, e to the r, x to the r, whatever you want to call it, right, 4 to the r is 4 to the r divided by the natural log of 4. So you're going to have to just add that to your little list of things that you now know how to integrate. E to the x, right, that's like e is 4 here, is e to the x over the natural log of a. And after that, you can do brute force. Are we good? Okay. That was just a weird integral that you've probably not seen for a while. Well, now we're getting into the fun ones. This is going to be like number 8. The integral from 0 to infinity of the square root of 4 plus x cubed, oh, a fraction, then x squared on the top, dx. So that's going to be the limit as t tends to infinity.
You
How am I
sub.
going to integrate that?
U sub.
Correct. And what's the u sub going to be?
4 plus x cubed.
And if you differentiate with respect to x, you will get 3x squared. If you do the crossover and then isolate. Does that seem familiar? U sub. So it's going to be the limit as t tends to infinity of an integral, the x squared is going to stay put for a little while. This guy is going to become that, and the dx is going to be replaced by that. These cancel out, and you get a third, which I'm going to stick there because it's just in the road. Right. Okay, we're stuck with a 1 over square root of u guy. How am I going to find its antiderivative?
Power rule?
Eventually, but what am I going to have to do before I can use it?
Turn it into exponential.
Right, and what fractional power is 1 over the square root of u going to become?
-1/2.
Agreed. So now I can do the power rule. Add 1 to the power is u to the half. Divide by that new power gets you 2. That's going to be the limit as t tends to infinity of 6 square root of u.
How do we go from 1/3 to 3?
I have no idea. So we now have 2/3 the square root of 4 plus x cubed. And now we can plug in the limits of integration, which is that guy. And that becomes this fella. Plug in nothing, you get 4. Square root of 4 is 2, so you get that. Okay, brute force time. What's this whole horrible mess going to be at the end if you make t infinite? You said something, but I think I would catch it.
Infinity.
Agreed. And so infinity take away 4/3 doesn't do any damage. This one diverges. Looking good? And when some diverges, you just type in the word diverges. I think you do it in capitals, yeah. D-I-V-E-R-G-E-S is the answer that goes in the box. What's this equal to, right? Just the word diverges. So that was a U sub. Question 8 was a U sub. Question 9 is going to be an integration by parts, or it's going to be a U sub. And it also has a big problem. There's 2 infinites, and we've never done 2 infinites. We've always had a number either here or here. Agreed? Now, you might think that all you do is stick a limit as t tends to infinity and make that negative t and plus t. Not a good idea. And because what you could end up with if you're not really careful is a plus infinity takes away a negative infinity, and the answer might leave you with a 0. And it'll also be wrong. Because infinities, remember, some infinities are bigger than other infinities, and so if you subtract them, there's no guarantee of anything, right? Not a calculation are allowed to do. So what happens is that this question becomes 2 questions. I'd probably pick 0. Does that make sense that that integral is the same as two separate integrals, the ones I've written down, added together? Great. Now for each one of these integrals, they become their own separate, in this case, the limit as t tends to negative infinity of t to 0. And this one over here, it becomes the integral as t tends to plus infinity So two distinctly different questions. You're going to do that one in total isolation to this one, and then you're going to do this one and total isolation to that one. Now, there are a couple of problems to be solved. What method of integration should I use to solve this integral? There's only two candidates, right? Integration by parts, U sub. Which should you use?
U?
U sub,
Agreed. Who's the U sub going to be in both cases?
negative x squared.
Right. Can you trust me that you just do all the stuff and it'll take 5 minutes, but you'll get the answer? Now, there are a number of possible things that can happen with these kinds of questions. So I'm going to go through each combination and then we'll see if we can figure out what the final answer to this guy is. Here's the easy one. Couldn't this be infinitely large and this one be infinitely large? In which case, won't the answer be, when they're both infinite, won't the answer be it's divergent? Agreed? Now, what happens if this is infinity? And it doesn't matter if it's plus or minus infinity, but it's infinite. And this guy over here is 4, or some number. What's the whole thing going to be equal to?
And plus or minus infinity.
Which means it's divergent again, right?
Yes.
So here's a little trick. If you break it into two pieces and you do the first one and the answer's infinite, will you not bother with the second one? Because the minute that's infinite, isn't the answer divergent? Now, this one might catch you. Suppose this answer is being negative infinity and this answer here ends up being plus infinity. Now that can happen. Here's two choices, only one's right. It's divergent or it's 0.
Divergent?
Correct. But you might think, but this is that and they cancel out. Well, if that was 7 and 7, they would. But couldn't that be the number of fractions in the world and the number of real numbers in the world? Couldn't they not cancel each other out? Because infinity doesn't behave well with other infinities, except to reinforce the fact that I'm infinite, right? So infinity to the power of infinity, not a problem. Infinity divided by infinity, problem. It's not 1. Couldn't the top infinity be a different, bigger infinity than the bottom one? Or the bottom one could be a bigger infinity than the top one. Or they could both be exactly the same infinity, in which case I guess the answer is 1, right? But you don't know with that. You can't really get into the depths of that. So you don't want to see that. On the other hand, is it okay to have 0 over infinity?
Yes.
Isn't the answer just 0? Is it okay to have infinity over 0?
No.
Actually, it is. What would infinity over 0 be?
Could it just be 0?
The wrong direction.
Infinity?
Well, if you take any number divided by 0, isn't the answer infinity? Infinitely big. So isn't infinity over 0 Really infinite. Extra
what?
infinite. So what I'm just trying to get together here is that, yes, you can do brute force, but will you be kind of careful about what you are allowed to do with infinities, right? You can, if it's an infinity and a number, you're in really stable ground, right? Any combination of infinity and a number, as long as the number's not zero, I guess, is fine, right? I can do that. It's when one infinity meets up with another infinity that problems can occur. It doesn't mean that there aren't some situations where we can do it. What do you think infinity times infinity is?
Infinite.
Right. What is infinity plus infinity?
Still infinite.
But what's infinity take away infinity? Don't know.
Still infinite. Okay.
Nope, don't know. That's that you got to have your kind of mindset. Don't think of infinity as like 4 or 42, because it'll bite in the bum. There are certain combinations that if they were numbers, it would make perfect sense that that would be true, but not with infinity. So be careful when you do brute force with infinity. Just be aware that, you know, certain combinations don't work well.
What was infinity divided by infinity?
Don't know is the answer.
Okay.
Undefined. It depends on how big the infinities are. You'd have to do, I would probably do L'Hopital if you got a question like that. Actually, I'm going to try and see if I can find a L'Hopital just to show you doing it, right? It looks like right now, hasn't everything been brute force? You just plug in infinity and off you went. Not doing this question, just want to give you a clue on how to do it. That guy there, how are you going to get the integral? What method?
U sub?
Correct. Now the trick is picking the right one. U sub it is, correct. What U sub?
The power of E?
Nope.
Just
Got you
X?
puzzled. Nope. Oh, X is never going to be a good U sub. So if you think X, stop thinking it. It's never going to help.
X squared?
Nope.
Oh.
1 over X?
Yeah, or negative 1 over X, whichever. Both will work. Can you trust me? In one you get that, and the other you get that. So it works. Isn't that one of the unusual U subs? Again, this is just to help you out. Not doing this question. This is like 11. Uh-oh. Not anymore. Forgot the time. Okay, say hi, everybody. Time for us to finish. Remind me that I haven't done question 11 tomorrow, because that's where we'll continue from. So I'll give you a few moments. As soon as you've said hi, it's a bye-bye. Unless you've got a homework question that you need some help with. Okay. Who's going first? Ian, might as well start with you then. What's your question? We'll do one from each person.
Sure. I had a question on number 9. It doesn't entirely give bounds, and it asked me for the exact length of the curve.
Tell me what it does give you then.
Sure.
It saves me going out and in and looking for it.
Y equals the square root of x minus x squared.
Oh, okay then. If you put that into your calculator, you'll find out that 0 and 1 is the only place that curve exists. So there's its bounds.
Oh, okay.
So it's going to be L equals the integral from 0 to 1 of the square root of 1 plus, yikes.
I think it ends up just being square root of 1 over x.
Oh god, yeah, yeah. So that's a nice pretty one, isn't it?
Yeah, assuming I did it right, but yeah.
It sounds too nice to be wrong, right? You know, it's when you get the square root of 1 plus x cubed over x squared plus 1 that you think, that doesn't look right. You know, but 1
Yeah.
over x looks too good. I mean, okay, maybe 2 over x, but it's in the right ballpark. I'm not sure that counts as a question. Have you got another one? Because that was really quick.
Sure. Number 8.
Okay, what does 8 do?
X squared over 4 minus ln x, all that over 2. And then the bounds are from
Oh,
1 to
ln
8.
of x all over 2 or ln of x over 2?
ln of x over 2.
Okay, so rewrite it. So that guy, I'll just call it a half x, right? Is that it? Right, and what's the bounds?
1 to 8. Oh, sorry. I think I misunderstood. ln of x is in the numerator, and then 2 is the denominator. Sorry.
I don't know. Can you see what I'm writing?
No, I can't.
That'll help. Can you see it now?
Yeah, that one.
That one? Okay, I'll just rewrite it again because it's a mess.
Sorry.
No, it's hard to verbalize because in mathematics, you could interpret the way someone says something in 2 correct ways, but only one of them ends up being the correct thing.
Yeah, it's also x squared over 4.
And that was just me
Yeah.
not paying attention. Right, so it didn't come out pretty, because that's the only thing I can imagine.
It didn't come out correctly, and I did it the second time, and I got the same answer.
Okay, if you differentiate this guy, you get 1/2 x. If you differentiate this guy, you get -1 over 2x. Do you get that?
Yep.
Okay, I'm going to pull out the half and just leave that for the time being. Okay?
Yep.
Right, now if you square it, you get 1/4, that guy. And if you add 1 to it, I'll just stick the 1 at the end, you get x squared minus 1 plus a 1 over x squared, add 1. Did you get that?
I just did not pull out the 1/2, so I'm trying to make sure I
Okay, I'll
did
just
that
keep going then.
right. Okay.
1/4 x squared minus 1/2 plus 1/4 1 over x squared, add 1. So you get 1 over 1/4 x squared plus 1/2 plus 1/4 1 over x squared,
Yeah.
which is a perfect square.
Yep.
Of 1/2 plus 1 over 1 over x squared.
Yep.
Okay, that's not where the problem went. Then the arc length is going to be the integral from 1 to 8 of the square root of 1/2 x plus 1/2 1 over x squared, which is integral from 1 to 8 of 1/2 x plus 1/2 1 over x dx. That half is really bugging me. I'm bringing it out now. Oops, that's 8. Oh, yeah. It's integral from 1 to 8. Pull out 1/2, and you're looking at that guy. So let's see. I'm getting 8s in my brain, and it's turning into infinities because of what we just did. So that's 1/2 x squared. That's the natural log of x. It's going to be evaluated from 1 to 8. And then we take 1/2 of everything. So it's 1/2 8 squared plus the natural log of 8. Take away 1/2, take away the natural log of 1. That gets you 64, 32 plus the log of 8. Take away 1/2, that's 0. If you put the 32, you get 63 halves, which gets you 63 quarters, plus 1/2 log 8. So I'm not quite sure what went wrong there.
Yeah, that's the. Oh wait, no, I turned that into a minus for some reason.
So that,
Okay.
so just a plus should be a minus, min
Yeah,
should be a
my
plus.
my ln 8/2 should have been a plus.
Okay.
Okay. Yeah.
Okay, we get someone else in the group. They may just be watching, that's fine, they're allowed to. Jocelyn, you got a question? Or are you just not leaving? Jocelyn's not here. Okay, Ian, you get any more?
Sure, we can do another one if you want.
Hey, it's up to you. Whatever's useful. If you don't have one, that's good. If you do, that's good too.
Yeah. So it'll be number 12. Okay. Y equals 2x to the power of 3/2. Yep. And then my starting point is p subscript
Oh.
0, 16 to 128.
Did you have a Q?
No.
That's it. I need
Yeah,
a Q.
That says find the arc length function of the curve.
Oh, arc length function. Okay, so
Yeah.
the other guy is basically going to be x, right? Okay, so s of x, the arc length function, is from 16 to x, and you turn the function into t's. So it's going to be the square root of 1 plus the derivative squared dt. That's basically it. So it's the same function, same arc length function. We're just going to have limits of integration from 16 to some arbitrary point x. So if you imagine this was 16, you started there and you finish x. So it tells you that distance there. Okay, what do we have? I have a y equals this fella. Its derivative is that fella. Its derivative squared is that guy. And 1 plus it gets you that guy. So our fella is the integral from 16 to x of the square root of 9t plus 1 dt, which I'm going to call 9t plus 1 to the power of half dt. Now you can either do a u sub of 9t plus 1 or you can use the linear shortcut method. I'm going to do the linear shortcut method. If you add 1 to its power, you get 3 halves. If you then divide by that, you get 2/3. And what does the 9t get me? Can't
Sorry,
hear
I
you.
was just catching up. For if we're substituting in our bounds.
Well, not yet, no. If you do the integration of this, you add 1 to power, you divide by the new power. But by the linear shortcut method, this 9 here also adjusts the answer.
Yeah, times 9.
No,
Oh, sorry, 1/9.
that's the one. So now we can do the t equals 16 to t equals x, and tidy that up while I'm at it. So 2/27. The square root of 9t plus 1 cubed. Take away 2/27. The square root of, good and grief, just some ridiculous number which I'm about to find out. 9 times 16 add 1 is 145. And there's really not much you can do with that answer to make it look particularly better. I guess you could pull that out, but that's about it. Oh, and I just made a mistake. It's even worse than that. It's 145 cubed. And that'll be your answer.
Okay.
So, yuck. You think they would make a nicer answer, but I guess you don't always get what you want.
Okay.
Okay.
Yeah. Thank you.
You're welcome. Do you mind if we just leave these on the video for the other people?
Oh yeah, that's totally fine.
Okay then. Well, thank you, and I will see you tomorrow.
Yep. Bye.
Bye.